Okay, but why we look at shearing stress?
Because you fail in shear first.
Yes. Okay. So I think Dr. Koshi did a demonstration, right? When you twist something, you feel in shear. Even in tensile, okay, you feel in shear. And if you look at a lot of materials, right, the failure in shear, the amplitude is lower than normal stress. Okay, that's why we look at shear stress. So later on, I'll touch on Tresca. Okay. So now, so for this case, you have to analyze your structure in what? In 3D. You cannot do what? 2D. I just show you. If you use 2D analysis, the value in I highlight in yellow is smaller than your what? Tau max. Your structure will fail. Okay. Some of you might say, Eugene, I just will throw a safety factor of 2. Okay. Listen. Yeah, you are right. You're absolutely right. Safety factor of 2 means twice more weight, more material. Okay. I promise to train our engineers to be more environmental friendly, okay, providing solutions that are environmentally more concerned or more minded, and also to the human to the human life. Okay. So now we have to do the right thing. Okay. So that is the importance of 3D Mohr circle. Okay. So now from here you can see that the tau max over here, okay, in the exact direction, it is your what? Out of what? Plane. Okay, it's out of plane. So how to find tau max? Okay, so tau max, so therefore, right, tau max is equal to stress x, okay, divided by 2. By observing the circles, okay, so this is our what? Stress x, okay, just divide, because your stress z is equal to 0, okay. And then if we so from here we can call this like your maximum stress is in stress x, and your minimum stress, which is your stress z, and this is equal to 0. So therefore, tau max is equal to stress max divided by 2. Okay. Now, this formula over here only is possible, only is true if you have this condition. Okay, you have this condition. Now you can flip y and x. You can flip over here. You can flip if stress y is greater. You can flip that, is fine. Okay, but it's only true if stress z is equal to 0. Stress x and y are both positive. So that is condition number 1. Okay. So this is what exactly I showed in court. Okay, why 3D Mohr circle is required for the analysis. But when is 2D possible? Okay, so that's why whenever I teach you guys, I always ask you all to find the maximum stress location. Okay, how do you know? You have to pick another point for me to show me that the other point that is also as critical is not highest. Okay, so the next point I'm going to show to you, when we have to apply 3D Mohr circle, when you can get away with just 2D. Okay, that is important. So probably that engineer over there was only taught 2D Mohr circle. Okay. So yep, I'm going to teach 3D Mohr circle is very, very important. I'd want you all to design structures that fail, and your undergrad degree is from McMaster. I don't know where to hide. Okay. Now, this case, condition number 2 is where stress X is negative. So it's in compression, right? Stress Y is positive, right? And then stress Z is equal to 0. Okay, so again, same thing. We are going to look at an element. Okay, an element. Don't worry where is the thick side of the element yet. Okay, don't worry about that. I will teach that. Okay, some of you are like, oh, he always draw it this way. He always draw it this way. Don't worry. Okay, so we know that stress X is negative. Okay, so negative, I'll make our life easy. I'll put this in here, right? And stress Z is equal to 0, and this is point X, Z. Okay. Then we start constructing 3D Mohr circle. So this is the normal stress. Shearing stress. Clockwise rotation, anti-clockwise rotation. So what we are aware that we know that stress Z is over here. Okay. Then we know that this is your stress X, which is compression. Then over here, this is your stress Y. Right? Then again, we pinpoint where our points are. So this is our point X. This is our point Y. And this is our point Z. Okay. So we draw our XY. Okay. We draw our circle for XY. Okay. So this is our circle for our XY. So this circle over here is for our X, Y, capital letter Eugene, come on, XY plane. Right? And XY plane is our in plane. And then the next circle I'm going to draw, right? So this is, so over here, this circle will be for our exact plane. Exact plane is out of plane. And then our final circle, right? This circle over here is for your YZ plane. You know what? I'm going to label this down here. This is our YZ plane. Again, this is our out of plane. Okay, so if you look at the tau max, okay, I'm going to draw the tau max. If you look at the tau max now, right, over here, this is your tau max. For your exact plane, okay, and it's not the maximum, right? Then over here, right, over here is your tau max. Over here is your tau max for your what? YZ plane, okay? And the final one, the bigger circle is what? Is over here. Right, the bigger circle you can see over there. Right, the bigger circle you can see over here. Okay, is where you have your shear XY, okay, max or shear max XY. And it's the biggest circle, yes or no? Biggest radius. So this is equal to your what? Tau max, and this is in your what? It's in plane. Can anyone make a comment regarding the final circle or condition number 2? Anyone? What can you say about this?
It's in plane.
The in plane is the biggest. What else? What else can you say? For this case, yes. Ash, what is it?
Yeah. It was in phase. I mean, in plane.
Sebastian, you are absolutely right. For this case, right, you can use 2D Mohr circle. You no need to do what? 3D. Okay? So not every case you can use 2D, 2D, 2D. No. Situation like what you have before, like what you see before, you have to be really, really careful. Like condition number 1. You cannot say, okay, stress Z is equal to 0. We take it easy, you know. We design whatever. It's like the Titanic. It will not sink. No, I'm not saying that this is the Titanic case, okay? That's why every situation you have to analyze, okay? That's how serious this topic is, okay? So from here, right, I'm going to write something out where we know that stress max xy is equal to tau max, right? So to calculate stress max, based on the circle, okay, I'm just looking at the circle, I'm not looking at any formula, is equal to stress y minus by stress x divided by 2. Okay, divided by 2. And we know for this case, right, our tau max is in plane. Okay, so when it's in plane, you can use 2D Mohr circle. So now if I'm going to let stress y,
Isn't the tau max always going to be for the circle that's going from left to right the most?
left to right. Yes, that's our tau max.
Like always it's going to be that?
It's always the biggest circle is going to be the tau max.
Okay.
Okay, so this is stress max, and stress x is equal to stress mean. So finally, the formula did change, right? So we have stress max is equal, or shear max equal to normal stress max minus normal stress mean divided by 2. Okay. So you can see, right, just different condition. The maximum stress, maximum shear stress change from out of plane to what? To in plane. So if it's in plane, right, if you have a condition where it's in plane, you can use 2D Mohr circle. Tomorrow, we can you always use 2D Mohr circle if stress X, that's the next condition we're going to look at, Sebastian, okay? So that is all I'm going to have for now. Tomorrow, the lecture will start at 9:30. I'll see you guys then, okay? Anyone have question? I'll still stay around. Thank you.
Thank you, Professor.
Thank you. See you guys then.